Did you know that the sun, the star that lights our day, can produce explosions billions of times more powerful than an atomic bomb? These explosions are called solar flares, and they are a fascinating display of the sun's immense energy. Imagine a sudden burst of light so bright it could momentarily outshine the sun itself. Solar flares are powerful bursts of energy released from the sun's surface. They are like giant explosions that send out light, heat, and radiation into space. This energy travels at the speed of light, reaching Earth in just over 8 minutes. While most of this energy is harmlessly absorbed by our atmosphere, powerful flares can sometimes disrupt our technology. Imagine the sun's surface as a giant pot of boiling water. Just like bubbles rise and burst on the surface of the water, energy bubbles up from the sun's interior. These bubbles create magnetic fields, which are invisible lines of force that surround the sun. Solar flares occur when these magnetic fields become twisted and tangled, like a rubber band stretched too far. When the tension in these tangled magnetic fields becomes too great, they snap and release enormous amounts of energy in the form of a solar flare. This energy bursts outward from the sun, traveling through space at incredible speeds. The intensity of a solar flare can vary significantly, with some being relatively small and others releasing as much energy as billions of atomic bombs exploding simultaneously. Why do the sun's magnetic fields get so twisted and tangled? The sun is not a solid ball like Earth. It's a giant ball of plasma, a superheated state of matter where electrons are stripped from atoms. This plasma is constantly moving, creating electric currents that generate magnetic fields. The sun's rotation causes these magnetic fields to stretch and twist, like rubber bands being pulled in different directions. Over time, this stretching and twisting can cause the magnetic fields to become unstable and break apart, leading to a solar flare. Think of it as a cosmic game of tug-of-war, where the magnetic fields eventually snap under the immense pressure. The sun doesn't release solar flares at a constant rate. Its activity follows a cycle of about 11 years. This cycle, known as the solar cycle, is characterized by periods of high activity, with frequent solar flares, and periods of low activity. During solar maximum, the sun's magnetic field is at its most dynamic, leading to more frequent and intense solar flares. Understanding the solar cycle and the mechanisms behind solar flares is crucial for predicting space weather, which can impact our satellites, communication systems, and even power grids on Earth. By studying these powerful events, scientists can develop better forecasting models and mitigation strategies to protect our technology from the sun's fiery outbursts.